Hi, I'd like to use this time to show you a little bit about our WARDCAM package. We developed WARDCAM to be a simple DXF to CNC converter. So I can just open up a DXF file here and quickly show you the steps that would be involved to create a CNC file to be able to cut on the Waterjet. Once you open your DXF file, it's designed to be a very clean interface. We only show the buttons that you need at that time. So it's very simple interface to work with. Over on the left there's some editing commands that I'll show you in a bit, but basically just going to show you the basic steps here to go through. Once you've got your geometry, you can just go up here to the top right hand corner, you can click on the next button, and in the next step here, typically all you need to do is specify the nozzle combination that you want to use to cut this part with, and you can add different nozzle combinations into the database, and then specify the material and thickness, and again you can add materials and modify the various parameters that go with those materials. If I go up to this database area, we've got the material database and the machine database, and I can show you those in a little bit. Basically, next step is where you add your lead-ins and your tool path. You can click on the auto button. It'll automatically put the lead-ins on your part. It does a nice job of collision avoidance where it's always putting the lead-ins so it's moving away from where it just finished cutting, so you avoid the potential of traversing across a slug. If you don't like where WARDCAM put the lead-in automatically, you can always just click wherever you want the lead-in to go and change the position. Once you've got your lead-ins how you like them, you can click on the next button, and in this next step here is where you create your CNC file. So up in the top left hand corner here, click on CNC and it'll create the code, and there's also a report that it can generate that you can give to the operator so he knows what program to load. So this is the CNC code. So it uses, we produce standard G&M codes, and you can modify the post processor to put out whatever codes you would need in there. And then there's also the report that it generates. Click on the report button. This will create a HTML file, so it'll show the operator the name of the file, information such as the part size, nozzle orifice combination, material type and thickness. You can type in any notes to the operator in here, and then the estimated time. If you have a Waterjet controller on your machine, we also have an optional barcode reader that you could purchase, and you could the operator could scan this barcode with the barcode reader and have it automatically load the program. So those are the basic steps to create a part. If your next part is going to be the same material and thickness as this part that we just did here, you can also use this fast forward button. So if we go back to the very first step here, we'll just open up a new DXF file, and we'll just take this one here. So we're also going to cut this out of 1/4" aluminum and use the 1030 nozzle combination. So I don't need to change any of those variables, so I can just click on this fast forward button. It will automatically add the lead-ins, create the CNC code, and generate the report if you want it to. So with one click of a button, you can have the part ready to go, have your report generated, and very quickly be cutting the part. So now I'll go back and show you some of the more advanced features that we have in WARDCAM. At any time, you can, top right hand corner here, you can click on any of these buttons to go back to any step in the process. So if we got to here and realize that we wanted to change something on our tool path, such as lead in position, I can just click on tool path. It'll bring me back to this step here. One of the things that you can do in this step also is you can change your cut qualities. Right now the entire part is shown in red, which indicates that it's being cut with the normal or Q3 speed. If you want cuts to be done at a different speed, different quality, you can change that very easily just by coming up to this list here in the top right hand corner of the various cuts. I can just hold down the control key if I want to select multiple cuts, and if I want those to be cut at a Q5 or smoothest, I can just come down to this list here and pick that, and then the color changes. And the other thing you can do in here is you can also change your cut qualities for partial cuts. So if, for example, this right edge here, the edge quality wasn't so important and I want to cut that edge faster, I can go into this partial qualities area, I can select a different speed, and then I can just click 2 points and click again, and the line changes color to indicate that this will be cut at a different feed rate. So that's how you can adjust your feed rates within a part. Also show you at this point, show you the material database. So if we go up to this database area, click on material database, we have a listing of various materials. If I want to put in a new material, say for example I wanted to cut 1¼ inch thick stainless, I can just highlight one of the materials and say add material, and it'll make a copy of that, and then I can come up here to type in the new thickness, and when I click on the calculate button, it'll automatically recalculate the feed rates from the Q5 to the Q1 for that new thickness. We can also define leads, length of lead-ins, inside lead-ins, outside lead-ins, and a other lead-in. If there's a hole that's too small for the inside lead-in, it'll use the other lead-in. So for example, I might typically make that shorter, like 50 thousandths of an inch maybe. So you can tell it the length of the lead-in, length of lead-out. If you want to do over travel, cut past where you let in, you can put a negative number in there. It'll go past there. For an outside cut, if you want to leave a tab, you can put a positive number in there, and then it'll leave a gap there. If you were doing piercing of glass where you wanted to use a circular lead-in, you can check these boxes here. It'll indicate a circular lead-in. And if you want to do a arc lead-in, you can check this box here for arc lead-ins. Also up here under thickness, there's a box for fragile. So if you are doing glass, you can check that box there, which will then automatically use a low pressure circular lead-in for materials like that. So if your pump has the capability, it'll automatically ramp the pump down to the low pressure for the circular lead-in on the pierce. So that's where you can define your lead-ins. If I click on the advanced button, other tabs show up down here at the bottom. We've got a ramping tab where you can define how many steps that you want to use to ramp down to the low speed on corners, and then it'll use those number of steps also to ramp up to the high speed. So if I go back to the feed rates tab, we have the high speed and the low speed. So the low speed is what it's going to go down to in the corners, and it'll use this number of steps to get down to that, and it'll use this distance to ramp down to that speed. If you want to do marking, there's a tab in here to define marking parameters, whether you're going to use abrasive and low pressure for marking and the feed rate and such. And then in the other tab, you can define what sort of feed rate you want to use on your lead-in. Typically, we suggest using the feed rate on the lead-in being 50% of the feed rate that it's going to use on the cut itself. So that's the material database. If I go back to the previous step, parts area here, where we told the nozzle combination that we wanted to use, we can look at the material database we looked at the machine database. So this is where you define your parameters related to the nozzle combination you want to use. So tell your orifice and nozzle combination, your abrasive flow rate, the maximum nozzle diameter that you're going to allow the abrasive nozzle to grow to. So it'll look at that when it's going into a sharp inside corner to determine how far into that corner it can go. Your horsepower on your pump, pressure that you cut at, maximum cutting and traversing speeds for your machine. If it's a 5-axis machine, you can also check this box here, so then you can program bevel cutting with WARDCAM. I can show you that. If it's a water-only machine, you can check this box, and then the abrasive information goes away. And if we go back to the very first step again, show you some of these editing features that we have over here on the left. If, for example, this DXF file came in and that line was missing, you can use this line command and you can draw a line from endpoint to endpoint. Doesn't have true CAD capabilities when it comes to drawing lines and rectangles and such. They're just used for editing, for cleaning up files if they do come in and they're missing lines. The rectangle command, I'll show you in a minute where that comes in handy. This point function can be used if you're going to be drilling a hole. So you can basically indicate the center of a hole. So if I wanted to point at the center of that hole there, I can click there, and then later in the process I can indicate that that's supposed to be a drilled hole, and then the code will be generated appropriately. The scissors here, you can use that to trim up geometries. So if the file comes in and two lines are extending beyond where they need to be, you can use the scissor and clean that up. So we've got this area here where these two lines need to be trimmed up, so I can click on the scissors and I can just click on the lines that we want to get rid of. Over here we've got a gap, so again I can use this line command and I can just draw a line from endpoint to endpoint. So as I hover near various areas of the line, it'll show me points that I can reference off of. So if I want to draw a line from, say, a midpoint to a midpoint, I can just find those points just by hovering near the line. And I'll get rid of that line there that I just drew. You can also do undo and redo up here, so if you do something, you want to undo it, redo it, you can use those arrows there. We've also got layer control, so this DXF file here came in with some extra geometry. I can either just delete that geometry, or if I want to hide the geometry, I can go into this layer here, I can shut off a layer and it'll hide that. And then if I wanted to delete, I can just draw a box around something and delete it. Also over here we've got move command, so if there's some geometry in here you want to move its location, highlight it, click on move, and then you can just drag it to wherever you want it to go. We've got the ortho button up here, so if you just want to move it in a straight line, either X or Y, you can do that. Also got the copy command, so if we wanted to make a copy of this geometry because we want to cut two of them, highlight it, click on copy, and you can, again, with the ortho on, you can just drag it straight in either X or Y. If I turn the ortho off, then I can, of course, drag it in whatever direction I want to go. And there's also a rotate command if you want to rotate the geometry. Scale command, so if something comes in metric, you can use the scale command and scale it up or down. And then there's also a mirror command. So that's some of the more advanced features that we have here. I'll show you what we can do with these points here in this next step. And actually what I'll do here is I'll just draw a point at the center of this circle here because we're going to drill that hole there. So I can use this point command and indicate that I want a point to be at the center of that hole. And then I'll do the same thing on this circle over here. So we've got those points that we can reference to tell that we want to drill those holes. So I just go to the next step. And the open contour cutting command over here, I can activate that menu, and then these lines here would be open contours, and as well as these numbers here if I want to cut those numbers. So I can just click at what end I want to start cutting at, and it'll recognize that as a geometry that needs to be cut, and then I can do the same thing for these numbers up here. And then I can come down to the other part and I can do the same thing down here. For these holes that we want to drill, over here on the right again, I can activate this point functions menu, and there's different options that you can choose in here. So if you just want to do an abrasive pierce on those holes, you can select that. If we want to drill those holes, select that, and then you can move your mouse near those points that we drew earlier, and then it'll recognize those to be drilled. And if we look over here, top right hand corner, it'll show us those drilling commands are in there now. These points that I put out here, I put those so for an example of if you wanted to put a optional stop in there. So maybe when it's done cutting the part, you want the cutting head to traverse out of the way so you could get the part out of the sheet. You can indicate that you want to do a stop, so then you can just pick those points also, and then over here in the list it'll show those commands in there. And then you can also reorder things, and we'll reorder them after we put the lead-ins on the part. So now we would just go to the next step again. And if I hit the auto button, it'll add the lead-ins on the geometries that we're going to cut. And so I can come up here, click on the order, and then I can go through the order so I can see how things are going to be cut. And then if I want to reorder things, I can use my arrows here to do that. The other thing that we can do is if we bring in a geometry such as this, where this is going to be a sink counter, and we just want to cut out the inside sink hole, and then this cut here for the front edge of the counter. Right now, if I tried to put lead-ins on this, it would see this as being an outside cut, and it would put the lead-in on the wrong side. So we've got the rectangle command, where you can just basically draw a rectangle around that geometry to indicate that that's supposed to be an inside geometry. I can go to the next step, and I can first of all specify open contour cutting for the edge here, and then when I go to the next step for the auto, I really don't want to do auto because then it'll put a lead-in on the outside. If it did, I could just of course delete it. So if I hit auto, and then I don't really want that outside lead there, I can just delete it. So then it'll create the code such it'll cut the inside contour and then cut the outside edge. The other option is, of course, you can just manually just add the one lead in for the inside cut. So then at this point you would just hit the CNC button, and it would create the appropriate code for that with the open contour cutting. And then the other thing we can do is if you have a 5-axis machine, we can program bevel cuts. So if on a part like this we wanted to put a bevel cut maybe along this bottom edge, I can show you how to do that. First of all, we would need to select a machine with the 5-axis. So if I go into the material database or the machine database again, this box has the 5-axis box checked. So first of all, I would add my lead-ins for the vertical cutting. And then over here on the right, we've got a pull down for bevels. So I can click on bevels. I can tell it to do either a top bevel or a bottom bevel. And as I click, it'll show what we would be doing there. And you can also specify the angle that you want to do that bevel cut at, and then how deep into the cut that you want to do it at. So since this would be 1/4 inch thick material, if we want to go halfway through there, we can specify 1/8 of an inch, or if you want to go all the way through, then 0.25 or 1/4 inch. So once you've told it that, then you can just click 2 points along the edge that you want to put that bevel cut on. So you can click there, and then you basically just drag your mouse so till the blue line indicates the edge that you want to put the bevel cut on. And then that blue line there represents that top bevel cut. If I wanted to put a bevel cut on a entire cut like on this hole, just basically click 2 points very close together on the geometry, and then again just drag your mouse so that the blue line is doing the entire hole, and then that will give us a 30-degree bevel cut on the top of that hole. If we wanted to do a bottom, it'd be the same idea. And if we wanted to do that on this hole over here again, just click 2 points very close together, and then just drag the mouse so the blue line is on the entire hole. So that would be how you could program bevel cut. So those are some of the features of WARDCAM. Hopefully you found that informative. If you have any questions, please let us know. Thanks.